Hello, this is Tim. I hope you're doing well. At this stage, um, you should have a nice model of an electronic enclosure block made out of aluminium, with all the features. It should look very, very close to this. If you can't do this, you might want to go back and you'd want to go over that video number one, advanced tutorials. What I'm going to show you now. Um, we're going to create this 11 by. We're going to create the drawing of this part. Now, excuse me. I've actually, this is my second time going through this. I'm after deleting my first attempt. I did it on an 8.5 by 11, and it just won't fit. Something this, there's a lot going on. Something this, I don't know what the right word is, complex. You'd put it on an 11 by 17 size sheet. In Europe or Asia or anywhere else, that would be an A3 size sheet if my memory serves me correct. Now, so let's start it. Let's have a go. So what are we going to do? I'm going to go File, New, Drawing, and I'm going to go OK. If you're in Europe or anywhere else, it's going to be A3. That's your paper. In the United States, we're going to go B ANSI landscape. It's 11 by 17, and we're going to go OK. This is your standard Solidworks title block. I don't need a lot of this information, so I'm just going to edit it and really quickly. I'm going to. So how do we edit? Come on, let me see what I'm doing here. I'm just going to get out of this business for a bit, or press X. There we go. I'm going to right click, edit sheet format, and I'm just going to delete all of this. And let's just put this line back in. Alright. Now I have this. So there's a title block, a proper size title block. The last thing I'm going to do is I'm just going to put a little logo on the top left hand corner of my college. It's a good habit to get into because, you know, some of you are hopefully, a lot of you are going to get a job with a company, and typically companies like when you throw their logo in. So I'm just going to go AACC logo here. Alright, let's go save image as. I'm just going to put this on my desktop. And let's have a look. Let's go insert, picture, desktop, logo, and let's just throw this in the top corner. Not too small. Alright, so let's go back here. So we have 3 sheets. This part is quite complicated. It takes 3 sheets. The first sheet is a pair of isometrics. These are just to give you a little history. Maybe I explained this part was actually made with a company I worked for before, and we would get a lot of our parts CNC machined, and then we would get them plated, and then we would get them painted. Now the plating on this part is something called gold iridite. It's not a gold part. It's just a gold. It's not even a gold coating. It's just the color of it. You know, I really don't know what gold iridite is, but I know it's not gold. It's a conductive coating, and I don't know why we used it, to be honest, and I should know that, but I forget. Anyway, and then we painted them with a powder coat. So this image here would have been used. Would have been given to the. I'm just going to pause this. I have a couple of my housemates are shouting downstairs. I can't even hear myself. Anyway, so this sheet we would give this to the painters. Essentially, we used painters in Baltimore, and they would have this would kind of indicate where the powder coat is going to go and where we don't want powder coat, so where to mask and things like that. So the next sheet is your 2D views, your front and side, and your section view, and a couple of detail views. And this part is a little bit hairy, so I had to include a third sheet which has a couple of these features on a front, top, the sides, and so on, and some information on the text. So you know, my feeling is if you can draw this part and create a drawing like this, you're in good shape. You know, this is a pretty typical type of thing you might do with SolidWorks. It's, I was, I'm still paid to do design work like this, so you're at a high enough level. I think so. You should be motivated. I think it's a good drawing to have in your prototype or your portfolio. So we'll give it a lash. So I'm just going to kind of no. So anyway, it's a 3-sheet drawing. So this is one sheet. What I'm going to do is I've created one sheet. Look, I'm going to fix this, and then we'll copy it. I'll edit sheet format. Now what is it? We'll call it a title. We'll call it an Electronic Enclosure Mechanical. Mechanicals. Right, we'll make this a bit smaller. There we go. That looks good. Drawing number. It's the what is it? It's 2016. It's the month of January, and we'll go the 23rd, and it's 01. Let's make this a little bit smaller. That looks good. We'll just let me just delete this bit of it away. She's 1 of 3, but I'll change that in a second. Size B. Come on now. Revision is A. That's good. And look, can I? Is there text there? Lovely job. I'm just going to go Anne Arundel, and you can put it in whenever you want, unless you're one of my students. All right. And then drawn T Cal. Date 23/16. Okay, alright. So I'll save that, and what we'll do here is I'm not a big fan of that font, but we'll leave it, it's fine. I'm going to press the click on the sheet, Control C, Control V, and I'm going to go OK, and then I'm going to press Control V again, and I'm going to go OK, and I'm going to click at this. I'm going to go right click, and we'll call this sheet 2. Right click, we call this sheet 3. Alright, now does that update? Lovely. Sheet 2 of 2 and sheet 3 of 3. It's not really what I want. Can we fix it? Yeah, we will. Sheet, yeah, it's working now. Hold on a second. Sheet 2 of 3 and sheet 3 of 3. That's what I want. Good stuff. Alright, right, we'll give it a go. We're going to put in the 2 isometric views. Alright, let's not go there. Let's go to Electronic Enclosure Project. Let's go isometric. Okay, that's not what we want. So watch this. I'll show you how to get the 2 views. We'll go model view. We do a front view. That's a back view. Projected view. Alright, let's delete. Now let's leave him there for the time being. So we have a front view and we have a back view, and what we'll do is we'll just get it projected, and we'll project off of that. So there's your front, and let's try that again, and there's your back. Look at that, lovely. Yeah, I'm much happier now. This is I was trying to do this in 11/17, and it was just a nightmare trying to fit everything in. Now they're too small. We'll make them a bit bigger. So scale on the left hand side. We'll go 1. I'm going to try 1.5 is to 1. Look at that, beautiful. And we'll do the same here. 1.5 is to 1. I'll go back here, and I'm just going to rip off this this note. This says that the material is aluminum 6061. That is the most common aluminium that is used in machining. The gold iridite were indicated, and the powder coat is some sort of color code that the painters will know. So what do? We go annotation, note. Lovely. Look at that. I'm going to make this. Let's throw that there like that. Now we'll just, I'm in the mood to put it down there for some reason. I'll delete this at the top, so we could probably make that note a little bit bigger. that does the job. Yeah, it doesn't look too bad. Alright, I'm going to save this. Save your work. Electronic Enclosure Project drawings. Where did I save that? Did I save in the right place? Not in Dropbox. Desktop. There we go. Okay. Right, let's have a look at this drawing number 2. Pretty lot going on there. Sheet number 2. We have a front and a side, and we have a section view. We have 2 detail views. So let's put those in. Alright. I'll go model view. Alright, let's put on the preview. This is the front. I will put in the back there. I'm just going to use that as an intermediate view, and we'll get that. Now we have the front. I'm going to delete this, and now this will be free again. We want them to be joined at the hip. I'm going to right click on new. I'm going to go alignment, align vertical, horizontal by origin. Look at that. Now they're together. I'm going to get a section view. I think that's the right way, is it? Nope. Let's flip it. Well, I wasn't paying attention that much. I think we're on the right way now. Okay, let's slow down for a second, and we need some detail views. So we need a detail view of this. There's USB going on there, USB connector, and then we have a BNC going on there. So we need 2 detail views of there and there. Okay. So I'll go detail view. And let's make this a bit bigger. I like it. And we'll do the same again. Believe it or not, right now there's a massive blizzard outside my window. This is the blizzard of the snow apocalypse of the 23rd. I'm looking outside now, it's pretty crazy, but you know, at least I can keep myself busy by doing this. This is something that's been hanging over my head for a while. I wanted to make these videos. So let's make this 4:1. Too big, that's too big. 3:1, that's too big. 2:1, that looks a bit better. But this is a bit big here. We need to make this a bit smaller. There we go. Alright, I'm going to make those views a little bit bigger. So if I start with here, let's go and let's make this maybe 1 point. I'm going a bit fast now. Let's make it 1.25 to 1. That's good, I like that. And let's do the same with this. That might be a bit big. We'll be able to fit everything around it. We'll have to make them smaller if that's the case. We'll deal with it. Okay. Now, you guys in Europe or Asia, you know this is an I can tell that it's ISO dimensioning standard. In the United States, we use ANSI. It's American National Standards Institute. You use ISO, so I'm going to change it now. It's up to you if you want to leave it. Document properties, ISO. I'm going to change this to be ANSI. And there it is, okay. Okay. So I have my views in. The next thing I typically will do is before I start throwing dimensions in, I typically go for the holes. I'll put in the whole call out. So we go to annotation. Once you have the views in, you know, there's no really set rule book for putting in views. You know, you want to make sure you hit each of the features. The whole point is to communicate to the machinist or assembler or the fabricator how they need to be able to see everything in the part. What else? You need room for your dimensions. And don't be afraid to have a third sheet if there's just not enough room. You just don't want to have you don't want to pack everything on a drawing sheet. It'll just it's just a nightmare to have to read. It's just a total pain. So you want to I don't know if the right word is empathize, but you want to sympathize with the person who's having to read your drawing. I'm not going to lie, I hate creating drawings. It's tedious as hell, but you just have to soldier through it. So anyway, whole call out. These guys here, alright, it's a counter bore. Let me put it down here. Alright, 4 times that, yeah. We'll get this guy going here. Whole call out. That's a 440. That's a type of screw thread. 080 here is a really small one, and I've broken so many 80-20 taps in my day. It's not even funny. Alright, 80-20. So let me see if I can explain this. What does this mean here? This means the person's going to come in, the machinist is going to come in with a 50 thousandths drill bit. They're going to drill down a depth of 0.1 of an inch, and then they're going to come in with a tap and ensure that there's at least 60 thousandths of thread. So typically when you pre-drill it, you're going to have more drill. You're going to have more of a tap drill. So you're going to drill deeper than the thread is. That's just the way it is. That's just how it works. Now I wonder, do I need those? Let's go back here. Did I put those in there? No, I didn't. So let's just delete those from here, and let's put them over here. Okay. Alright, now in this sheet what I've done is I've been lazy, and what I've done is I've packed it in with something called ordinate dimensions. Ordinate dimensions are nice because you can pack in a load of dimensions in a small area, but the machinist has to read them. So this is called our datum, our ordinate datum line, and everything is related from that. So this is going to be 0, 0. Look, in this type of thing they're nice, it's a pain putting dimensions in. And you can really pack them in. So what do? We go ordinate dimension. This is going to be my 0, 0, and I'm just going to hit these points. I'm going to go back and I'm going to hit right click this view, and I'm going to turn off the tangent edges. Alright, and that'll help a little bit. That's just going to get those little fillets out of the way. I'm going to go in and put in some center marks. That looks good. Now what are we missing here? We can always right click and add more. Add to ordinate. Can we keep on going? Lovely. I'll tell you, it makes life easy. Look, I don't like saying this to my students because it gives them a green light to be lazy with drawings, but in 2006, when I first started drafting about 10 years ago, drawings were everything. Everyone looked at drawings. Now what's happening is a part like this would be machined up in Mastercam, and the person will just bring in a step file or an IGES file or an STL, and they will just import it in and work off the drawing. The reality is I'm creating designs right now, and I'm not creating drawings, thank God. So that's a nice thing. Right, let's go here. Let's put in more ordinate dimensions. So what is it? It's 0, 0 from the top there. 0, boom, boom, boom. Look, you just take your time and make sure you're hitting everything. Okay. Now what's going on there? Good stuff. Alright. Are we missing anything else? We have all the whole callouts. Right, we're missing some fillet. We're missing some hole sizes. Radius 24, and I'll come in here and I'll go 3 times. Kind of space them out. So that's pretty good. Another piece of advice: whenever you're creating drawings, and I'm definitely not doing this now, but what you kind of do is you imagine if you had to machine this part yourself. This is why the best drafters are and mechanical engineers are people that have machining experience. I know. I'll give you a small example. I know I need to start off with a block. So the block is 4.28 by 1.6, and then I have its thickness. That's the first thing I'm going to do. The second thing I'm going to do is I'm going to cut out this area. Now I can see that I'm missing a radius. So I'll add the radius in. Let's put in ×4. That's next. Next thing I know is I need to mill out these 3 holes, and I can see I'm missing dimensions all over the place. So I don't know what the distance is from there to there. So I'll go around and I'll go add to ordinate. Alright, that's that. I have that. I have the centers of all of those. This is looking pretty good. I'm missing a fillet there, or a radius there. Let's put it down here. So typically, you can either pretend like you're machining this part out yourself, or what'll happen is, or you can just, like what I used to do when I first started drafting, is I used to just put in a shit ton of dimensions, and whenever you miss something, you always got a fax back or a machinist on the phone asking you what depth is that, Tim, or what size thread is going in there, or what is this fillet here, or can we make this a little bit bigger? It's going to be a nightmare to machine that out, or whatever, stuff like that, you know. So anyone that's designing parts, my best advice is to be very respectful and be friendly with your machinists, because they're a lot of help. They'll tell you, they'll give you a lot of good advice for free. Right, so let's have a look. Let's what's the next thing we'll do? We'll look at this next view. I'm going to take a break here for a second. Excuse me. Right, so I think now is a good time to save this work. Okay, so we have that. Alright, what are we missing here? Let's start by putting in this view, we'll start by putting in some radiuses, because I'll forget about those, and then I can add in the ordinate dimensions. Alright, what radiuses do we need? Let's put that one in there. It's nice. I started drawing this this view here in 8.5 by 11, and it's such a pain when you're trying to fit stuff into a drawing. I was doing this before, trying to make a video out of it. I was just getting frustrated trying to pack all this into a smaller drawing. So you know, if you feel like your brain is getting melted by trying to fit information into a page, you need to stop what you're doing and start again and put it on a bigger page. It's just do it straight away, you know. So I'm just getting my ordinate dimensions going here. I'm gonna add more detail on this down in this view here, but look, I'm one of these people. I believe in adding more. I believe in adding more dimensions. Some people are against that. I don't see it as being a big deal if you're adding a couple of extra dimensions in. So what? So don't worry about it. All right. I started from the top. Don't worry about this, it would clean itself up. It figures it out. We might have to do something about that there. Let's add this, and we'll add that. Anything else? Got that, and we have that. Alright, okay. So we don't want this, so we're going to have to pull this line out, and I forget how to do that. Let's go edit cutting line, edit section. Can I drag this out? Be a good lad. Ah, yeah, good stuff. Alright, and here on this view I have a fillet. I gotta put that in there. Let's drag this down a little bit. Little fillet there. A little ball end down there. That's it. Alright, let's get our got loads of room on this side. I'm not a big fan of that hatch. I'm going to do something with it now in a second. Yeah, we definitely want that. Okay, that fixes that. Good stuff. How do we fix the hatch? What does this material cross hatch mean when this is checked? This means the Solidworks goes back to whatever material you applied to it, and I'm not sure what I did, but it could be aluminium. This is the material crosshatch that it wants to use. I'm just going to use what I always use, which is just the straight lines of 45 degrees. In mechanical engineering, I better be careful here. I don't think typically we care about, we're not that good at recognizing hatches. That's more of an architect's gig. So I'll uncheck that. I'm going to make this ANSI. Yeah, it's not roof shingle, that's good. Alright, that's not right either. I'd have to eat my words here. It could be one of these ISOs. No. That's better than nothing. Alright, and we'll change the look. That's okay there. Yeah, I like that. That'll do the job. I don't know, I'm just picky when it comes to hatch for some reason. I've been just doing this too long. Alright, so that's that section view. It's looking good. You guys in my class in ENT 261, you better make sure you do this on 11 by 17, okay? I'm going to make you redo it if it's on 8.5 by 11. I feel like I want to change yeah, I need to change the precision on this. So I'll go Tools, Options, Document Properties, Dimensions, Precision. Let's make it three decimal places. There you go. Let's put in some fillets. 0.38. Is this all 0.38? Yeah. So we go 0.38 T by P. Alright. Right, what else am I missing here? We have that, the width, I think looks pretty good. That's in the center. We put a center line in. That's not too bad. Drag it a bit closer. Okay, that's that done. Let's get a radius on this. We have the hole size. Let's get a radius on the fillet. Times 4 places. An electrical connector is going through this hole here, and then we have these threaded holes. It's called a flanged BNC connector. You should look at it. If you're doing any sort of work around Baltimore or Washington or Annapolis, you're going to be doing probably defense work or electronic work, and you know, you're going to be putting electronics into a lot of these packages. So you best start learning what the different connectors are. So that's a flanged BNC that's going to fit in there. Okay. Alright. I'm going to save this, and we'll move on to looks pretty good. I'm happy with that. Alright, I'll save it again, and we'll move on to sheet number 3. Now let me just double check that what we just did. Okay, that looks good. We can move this over a little bit. Okay. Let's look at sheet number 3. So we have a front, we have a top, and we have 1, 2, 3, 4, 5 views, and then we have these notes. Let's just put these notes in at the start. So I'm going to go note, put that down here, make it a bit bigger. This doesn't seem right. I'm going to have to go back and change that. That doesn't seem right. Yeah, we've got a text emboss. The text engrave height is text emboss and sunken platform height 50 thousandths. Seems a little bit big. We'll go back. What did we end up doing on the drawing? Let's have a look. Now what was this depth? It looks like from there to there is 50 thousandths. Okay, that works. And then, but I think this is a little bit less. Look, we'll just leave it the way it is, 50 thousandths. Okay, we'll get a model view. I'll get a front. I'll get a side. Is that the right? Why is that changed? A top and a bottom. Let me just check something here. That seems right here. On this drawing, did I not change the first angle and the third angle? I just want to double check. Yeah, it's third angle. That's okay. Alright, if you guys, if you're anyone else outside the United States is having a problem getting my views to line up the way they are, you want to just double check here down in properties, make sure this is third angle. Now whenever you're drawing, creating drawings for home, or if you're in the United States, make sure this is third angle. Anywhere else, make it first angle. If you're in the United States and you're getting parts made, say in Asia or China, or Europe even, then you're going to have to change this to first angle. Okay, so I would mention that in the class. Now, I'll click here and I'll go just lines. Lovely. This is looking good. What do we need to say here? Okay, so we're just doing this on this view here. We're just calling out those pockets. Boom, 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 boom. Alright. Come on now. There you go. I'm just going to show you something. These pockets that you see here, this one on the top and this one on the bottom, they would be made with, and the machinist will know this, they will be made with something called a ball end mill. Okay, so that means it's not going to be a straight mill. It's going to be a ball end mill, or a bull nose end mill that will cut that will give us that curve there. So that's something you're going to have to start thinking about, stuff like that. Now I did put in a note. I went like this, platform 0.1 inch depth. and we'll do both sides. And what I'll do is I'll right click here and just give that an arrow. Alright, is that everything on that view? But fillet, let's just put that in there. Okay. Let's be careful here, not that. I think we want the outside one and there. Okay, let's delete that. We'll right click and go, can I just delete that if I want to do delete? Good man. And is that a fillet on there or a chamfer? That's okay, I'm gonna highlight all this. I'm looking outside now. I'm gonna have to shovel for about an hour. I've got so much snow at the back. Alright, a note. We'll call this 25 thousandths by 45 degree chamfer, 2 places. Okay, and then we'll just do this. We go from there to there. Okay, we could probably make these views a little bit bigger. Oh yeah, alright. This is looking good, I'm happy with this. And we'll do the same over here. And we need to put in a note here. What is the platform? The platform is it's 25 thousandths deep. So we go note, we go in there, and we'll go 0.025 inch deep. Both sides. This is overkill, but I'll dimension this side as well. Yeah, if you didn't add dimensions in this, you can be sure. Well, you would have back in the day. A machinist would have called you up and checked you on it. Now they would just open it up in Mastercam in a step file, and they will just be able to check it themselves. Okay. So we have that. I'm not even going to bother. I'm too lazy to put dimensions on that side. We're just going to put in this information here. No, try it again. That works. That'll just help the machinist. We go from there to there, 0.238, and then we go from there, come on now, to the edge. Let's try that again. Let's put him there, looks good. Let's put that there, that looks good. And they'll just center that text. You could even tell them what font it is. It looks like it's Arial. You would tell the machines what font it is. I think that's everything now. I'm going to save that, and what you're going to do is you're going to go File, Save As, and you're going to save it as a PDF, and you're going to email me that PDF on Canvas, and I'm going to grade it. So that's looking pretty good. If you do a drawing as good as that, I'm going to be very pleased. And so I hope everyone is staying warm, and I'll see you soon.